If you think that the model deployment is the final step in any MLOps project, you're wrong. We have an important step that's monitoring and the feedback loop. In this video, I'm going to break it down about the importance of monitoring and the feedback loops and how you can think about implementing in your MLOps project. Let's dive right in. When we think about any application, we'll not just deploy and forget about it. We have to monitor it. We have to monitor it, whether it's the personal resource that we use, whether it's the car, laptop that we use it in personal life. So if you don't monitor and maintain it, it will not come to a longer time. Now think about the complex machine learning models that we are going to deploy it. Now, first of all, deploying itself is a highly complex one. It involves various teams, various technologies working together and finally deploying it. And if we just keep it as it is without monitoring it, then it's going to become costly to the business because if we don't monitor, we don't know whether the model that's deployed, whether it's working as per our expectation or not. And that's where the importance of monitoring and feedback loop comes in. Now, in today's session, I'll take you through what does it mean by monitoring and feedback loops from the MLOps standpoint and what tools that we have got. So let's get started. First of all, for every one of you to be on the same page, so what is MLOps? It's a combination of DevOps and the machine learning practices. Like it combines the machine learning and DevOps practices to streamline the development and the management of these machine learning models. And that's what the MLOps is all about. It just bridges the gap between the data science team and the operations team. Now that we have understood what is MLOps, now the next question is, why do we need to monitor? Okay, like what is the goal of this MLOps before I take you to the monitoring? So the goal is we can achieve automation, ensure that we are able to scale it, increase the reliability and continuous delivery of the machine learning models. And that's what the MLOps is all about. The reason this monitoring matters in MLOps because, as I've highlighted earlier with the example, from the perspective of machine learning projects, by implementing the monitoring, this is going to ensure the model works at peak performance. We can ensure that the models that we have got in production, it's working in an optimized and in an appropriate manner, and we can track the performance of it. And another key thing that would happen, which may not be the case for general application, but it's very true for machine learning projects, is that data drift. So with effective monitoring techniques, we can identify the data drift as well as the model drift so that we can still maintain the accuracy. And whenever these things occur, we can take the necessary action and alert the right teams. It can be alerting the data science team to ensure that the model gets updated and the business can actually get the model updated and they will be having a better performance in the production environment as well. And another main aspect, which is very important even with generative AI, is compliance. With effective monitoring in place, we'll be able to meet the governance and regulatory requirements. And lastly, we'll be able to prevent the downtime. If we don't monitor our models and if the model starts reacting in a way that we have not handled in our application, then our users will be experiencing a high latency for accessing the application. But if you are not monitoring it, then it's like a downtime for the application, and we as an organization will not be aware of it. So, by having the necessary and the appropriate monitoring in place, we'll be able to proactively address the issues before they actually impact many users. Now, how can we achieve such kind of monitoring? Because the applications, when we talk about the machine learning applications, it's not same as the general application that we have got, that's the software application. If you think about it, in the software application, we'll have a code, we'll have an input. The input will be reaching the code, and the code is going to process this input and it will generate the output. That here, when we think about the machine learning project, not just the code, it's not just the logic. It's made up of three core component, as I normally say. The three core component that we have got is, first one is code. I'll say this as the ML code. And the other component that we would be having is the data set and the configuration, which is the maybe the configuration that we have set specifically that will be picked up in any algorithm, or it can be the setting that we have made. So combining these three, we are going to have a model. Now, when we are monitoring these machine learning models, we have to be considering all the three aspects: our ML code, the data, and the configuration. Which means the way in which we track these elements compared to the general software application is very different. So let's have a look into those metrics so that you understand what those metrics are. So here, when we take a look into this key monitoring metrics, so let's have a look into the model specific metrics. So coming to the model specific metrics, we have accuracy, precision, recall, and F1 score. So these are all the commonly used classification metrics. I'm assuming that I'm using the task of classification. So depending on the various tasks, we'll be having the respective metrics. So for simplicity, I've just considered the classification. So these are all the metrics that we'll be dealing with to measure how well the model is generating the output for the given data. Now, this means I'm taking an input and I'm getting the output. I'm measuring whether the output is right or wrong. So to measure that, I'll be using this model performance metric. Next, this model will be running on a server. Now I have to monitor those as well. So here, the other operational metrics would come into picture. The other operational metrics are latency, throughput, error rate, which are very much similar to the general software application. Here, it's basically measuring how much time it is taking to generate the output for the given input data, and how many concurrent requests is it able to process it, and how many requests are in queue if it is a real-time queue that I'm talking about, and what is the error rate that I'm dealing with. So all these comes under these operational metrics. And another critical aspect about our machine learning projects is the data. Here, we also have to monitor the data as well. That is not just the output that we have to monitor, which we will generally do it in the software application, right? But here, we also have to monitor the input, because data is also a key component in our machine learning project. Here, under these data quality metrics, we have data drift, we have feature distribution changes. So these are the two commonly used metric. Now, apart from that, we also have other metrics as well. Like for example, if I'm working with generative AI based project, and if I'm monitoring this generative AI for the generative AI application, my other metrics will be toxicity, and maybe facts. I'll be checking against a fact whether it is factual or not. So I can add those other additional metrics, and we'll be monitoring it for both input and the output whenever we are working with those generative AI projects as well. So to recap, if we want to monitor the machine learning projects, so we have to think about monitoring from all the three angles, that is model performance metric, operational metric, and the data quality metric. Now, another key thing that that the common approach that would be used in most of the projects is the real-time inference and the batch inference. Let me tell you an example. Let me just give you an example as the difference between the real-time monitoring and the batch monitoring. See, the real-time monitoring is works in a specific manner where you would go ahead and hit a submit button and you're going to see a response. Like, for example, let's say you're filling up the form. Okay, so you're filling up a form, and when you click on submit button, the form will be saved into a database and you'll get an automatic message that says as okay, your form has been submitted. That's like a real-time response. To give you an example, let's say if you're transferring your amount from your account to your friend's account, so you'll just make use of your banking application and hit the submit button, and amount gets deducted and it will be updated instantly. That's called as an instant or a real time. Batch is nothing but where the system is going to collect set of requests and it is going to process it in a sequence, or it can be in a batch wise format, like it can be hourly or it can be 15 minutes depending on their architecture setting. So that's those are the two kinds of inference that we will be seeing in the machine learning project. Now, even in such scenarios, we have to be monitoring as well. So let's have a look into that real time versus batch inferencing. See, under this real time monitoring, so as I mentioned earlier, there will be immediate detection. And whenever there is a prediction that's happening in an immediate manner, we have to monitor it such a way that we should be immediately able to detect it and respond to those issues. And this is, as I mentioned, this is generally used for immediate response is actually required when the application demands that. And this real-time monitoring is suitable for application which requires instant reliability. So that's when this real-time monitoring is important for us. Like, for example, think of it in this way. Let's say you're working with OpenAI ChatGPT or Gemini. Now, let's assume that that's the application that you're monitoring. And when someone, as an end user, tries to interact with that OpenAI, ChatGPT, or Gemini, and if that model doesn't give me a response, that's a triggering point where we have to trigger the developers and the infrastructure folks to look into it as, hey, what is happening over there? Because it's something that has got an immediate impact, and that's where the real-time monitoring comes into picture. And we also have the batch monitoring. Now, in this batch monitoring, where we'll be conducting the periodic assessments and we'll be doing the reporting, and this is ideal for less time sensitive application. Let's say whatever that you're building, the application that you might be building, not time sensitive. It's just for an information purpose. In such scenarios, we can continue with this batch monitoring. Okay. And the another aspect about the monitoring is the feedback loops. Very important that we also set these feedback loops in the MLOps. So what exactly is this feedback loop? It's a process that use the output from a particular system so that it can make adjustments or improve the future response. Now, there are two kinds of feedback loop whenever we take it in general way. It's called as open loop and closed loop. So let's understand the difference between those open loop and closed loop. So when I say closed loop, it's like an automatically one. Like, for example, it's a scenario where it will automatically retrain and deploy the models based on the feedback. Like, for example, we have maybe a data that's coming in. It found that the data drift is happening, and based on the detection of the data drift that you have done, it could be either real time or batch. So based on the trigger that you have set a feedback loop so that it will make use of the latest data as well as the latest approved data. Combining those, it will go ahead and retrain the model, and it will follow the CI/CD process and deploy the latest model. This is an example of a closed loop. And there can be an open loop as well. Now, open loop is a scenario where we have not defined the automation, but we want it to be notified so that the business and the data science team can take an action. Now, this is a scenario where we require an manual intervention. Now, that's called as a open loop. Now, with these kind of loops in place, especially in our MLOps project, this is going to enable the continuous improvement and, more importantly, the adaptation of our machine learning models. If I want to describe more about these feedback loops at a very high level, we'll be having a data collection, which is going to collect the data where we will gather the real time and historical data. It could be from multiple production, it could be from a production environment or from our historical data as well. And validation, where we check the integrity and validity of the data. Like this is a scenario where the data that is being coming from various sources. Let's say I'm working with the streaming data and I'm making use of various services. It can be Kafka streaming or it can be Kinesis data streams. I could be using any such services and I'm capturing those streaming data. And while capturing, before I actually place it into my data lake or similar architecture, I'll do a validation to check whether the formatting is right, whether the data is correct or not, whether the data is present or not. So we can check, we'll be setting up these kind of data validation, which is part of the feedback loop. And model retraining, that's one other example where we update the models with new data and the deployment automation. So these are all the common components for effective feedback loops whenever we are implementing this MLOps project, guys. So this was about a quick walkthrough and an idea about the monitoring and feedback loops in MLOps, guys. I hope you had fun learning in this video. So folks, if you want to join live from the next session, just check out the link that is provided in the description. Join our community and I can't wait to help you in your MLOps and generative AI journey. Take care guys and I'll see you next time.